everyone. I'm Seb from the UK, and today I'm going to be telling you a little bit about my mastery project where I was looking at machine learning and driverless vehicles. So, a little bit about me. I'm Seb O, and I'm interested in the future. Foremost, how can we prepare ourselves for the world to come? So this was something that I investigated throughout exploring AI, as I believe it's a skill that's really useful to know about and will help me prepare for the future. Here's a quote about AI from Dave Waters. Machine learning will automate jobs that most people thought could only be done by people, which impresses upon me the importance of learning about such a topic. The driving question for this project was how can I utilize my understanding of emergent behaviors in a machine learning training environment in order to create a real-life agent. Now, this was something that I was looking at as it would allow me to create a driverless car using AI and machine learning that could focus on safety and most efficiently transport people from place to place. Next up, you may be wondering what machine learning is. Here's a link between machine learning and AI. AI is the encompassing overall set that machine learning is a part of. Within machine learning, there's reinforcement learning, which I use to train my AI, clustering, classification, and deep learning. Now, why is this project important? So first, AI will have a big role in the future. Most things nowadays use AI, such as Beto and Drew's Think Wallet project, use some machine learning. And secondly, it's a really interesting topic. I really wanted to learn more about it and continue to learn about this in university, something that I'm going on to be doing. How does an AI learn? So there's 3 stages in the reinforcement learning cycle here, which is something that I use to train my AI. Stage 1, it perceives and interprets the environment, so it knows about the place around it. Stage 2, it takes an action or makes a decision based on this information. And stage 3, it learns through a reward or punishment, either gets told, yes, that was the right thing, or no, it was not. Next up, we've got a video demonstrating how this works in action. This was one of my first machine learning tests, and we can see how AI really works here. So the little dots moving around are the AI. They're tasked with a goal of touching the orange dot. They know where they are, and the orange dot is. Every time they hit the wall, the box turns red, and every time they hit the goal, it turns green. Now they learn over time to hit the dot more and more often, and as you can see here, they're turning green, which is a successful AI, and over time, they're working a lot better, which is exactly what I aim to do. Moving on, how did I build this? I use Unity, which is a development program I've used a lot throughout TGS. I created a VR project on this in Mexico, and now I'm using the machine learning toolkit inbuilt within Unity, which gave me a lot of freedom to design my own physics environment with which to train the AI. I created a driverless vehicle with set inputs, so it knows what material it's driving on, whether that be the road or not. It knows what heading it's going in and what its speed is, and then it uses this to work out whether it applies brake, acceleration, or turn left or turn right. Here's a video of the early training of the AI. Not amazing, as you'll be able to soon tell. Driving around in circles a lot. No clue what's happening, but there's some learning there. For example, it knows when on the road to drive more slowly, and it's slowly learning how traffic lights work as well. Over 112,000 seconds, just equivalent to 1.3 days, I trained this AI in batches. Every time I wanted to add a new feature to the AI, I had to go back and retrain it, which took a while. But overall, here's the final product and the trained AI that I created. It's got the ability to start more slowly than the previous version. This is, the last one was sped up, this is slowed down. Still a little bit of jaggedness in the driving, but it's able to drive through the traffic light, keep up speed, perhaps not the safest for passengers, but it's doing its job of getting the passenger to the location nice and quickly. Now coming up ahead, there's a corner, what's it gonna do? Does it know to brake or not? It knows a little bit, but unfortunately it fell off the road and crashed the car. However, this is a demonstration of how AI can be used relatively quickly in order to train driverless vehicles. Although it's not perfect, it's definitely getting there. And with the resources of a large company like, say, Tesla or BMW, I'm sure they're able to produce a much better AI model. Now, here's a graph showing all the inputs and outputs of this AI, although pretty confusing to understand. We've got a lot of key features, such as the reward is getting maximized over time. The AI is getting better. And in the middle, we can just see a lot of jagged values, which are the AI's outputs and not really easily interpretable by most people. But there are some graphs that we could understand from this, for example, such as the distance value, how far away the AI drives from the start point, and what floor it's driving on, whether that be road or the grass is correlated. This tells us that basically the further away it drives, the more likely it is to drive off-road, which is not what we want. However, these values show us what we can do in the future to train the AI to be better. Now, AI is a powerful tool if used for the right purposes, something I've learned from this project. Although it doesn't look with my AI that AI is going to be taking over the world anytime soon, it's really amazing and can be used in a range of ways. Now, I'm going to be going on to look into AI a little bit at university, something I'm really interested in, and I'm also going to be messing around with AI more in the future. Thank you very much for watching. You can find me on LinkedIn at Seb Olsen and on email at sebo@thinkglobalschool.com.